Hello everyone, this is Mitch, and today I'm here at Skidmore College. Just behind me you're looking at the Geothermal Energy Node project, which was designed by my good friend John Manning and built to a great extent by yours truly. I'd love to give you a tour of the system, so why don't we go ahead and get to it. So I would guess by this point you're probably wondering what the heck all this stuff is and how it has anything to do with geothermal. I'm here to try and help explain a little bit of that. All the hardware that you see is here for two basic purposes. The first of which is to provide fluid flow to and from the geothermal loop field, or to and from the ground. The second purpose is to provide a point for the buildings to circulate fluid to and from the node. So this is what would be called a primary-secondary pumping strategy. So I think the best place to get started is to describe the primary aspect of the system, which is to provide fluid flow to and from the geothermal loop field. But before I can do that, we need to understand why it is that we're looking to create this flow to and from the ground. The reason that we're doing that is that we're looking to, in the case of heating, we're looking to extract heat from the ground and return it here to the building where it can be utilized by the geothermal system. Seen to my right is a header which is supplying the loop field with fluid. So the fluid is being sent out to the loop field and being returned on this header. Now each of these headers has a total of 17 taps which exit the building and connect to the loop field below ground. Now each 3-inch line connects to a total of 3,500 feet of 1¼ pipe. So 17 times 3,500 is 59,500 feet of buried vertical pipe. We have a tremendous amount of thermal mass to utilize. Now under normal operating circumstances, we're only looking to get about a 5-degree rise from the loop field. So if we're leaving the building, we want to gain about 5 degrees of heat from the earth before we return. And although 5 degrees may not seem like a lot, when the system is operating under maximum load, that can be equal to over 300,000 BTUs per hour that we're able to extract from the earth, which essentially, minus the pumping watts that it took to get the energy, was free. So at this point we understand that any fluid that goes out to the loop field must come back and gather at this header. Now let's explore how the fluid is actually circulated through the system. So we're going to follow this line, which goes into a rather large air separator unit and continues on over here to that upper header, which supplies each one of these variable speed pumps with fluid. Again, that's from the source or from the loop field. Now if you were standing here and you could see on the other side of the camera, you'd notice that I've got a big old smile on my face, and that's because right now you're looking at German efficiency at its best. Seen here are a total of 8 beautiful Velo Stratus variable speed pumps. These are the pumps that are providing fluid circulation to and from the loop field. And the unique part about this setup being is that each pump is individually controlled and variable speed, is that we are able to deliver exactly as much pumping power as required to give us our desired temperature difference or differential across the loop field without wasting any power. Now, in order for us to properly understand the relationship of the temperature difference across the loop field and how many pumps are required to be running and at what speed to maintain that difference, we must first understand the load. The load is the secondary part of this primary-secondary pumping strategy. Seen here are a series of closely spaced tees. There are 8 in total, which provide a fluid path that connects each of the 4 campus buildings to the energy node. Now, it is important to note, due to the direction of flow in this system, that the first 4 taps are all supplying the buildings with fluid, and the last 4 taps are returning from the buildings. Now, this is an important distinction, and we do this because we want to ensure that the warm water from the loop field reaches each of the 4 buildings, where the geothermal heat pumps can then extract this free energy and efficiently deliver those BTUs to heat the desired space. After the heat pump has extracted the heat from the incoming source fluid, the fluid is then discharged and returns to the node on one of the 4 return lines, which has been strategically located downstream of the building supply taps, thus preventing any unwanted thermal mixing between the 2 fluid streams. Now that the fluid has returned back to the node, there's only just one place left for it to go, and that would be back to the ground, where it can steal some more heat from good old Mother Earth's cookie jar. Hey everyone, this is Mitch, and I'd just like to say, on behalf of myself and everyone else here at the node, we hope you've enjoyed this evening's production of... What was it that I was doing again?